Welcome everybody to the Get Healthy brand webinar. I'm excited to be announcing our featured brand, BodyBio. I'm Candice Lunardini. I am a certified natural health professional, and here at Get Healthy, I'm an account manager for the East Coast. And with me today is Justine Stenger, who will be discussing restoring mitochondrial function through phospholipids and redox enhancement. We have some updates here. Don't forget to register for our next webinar on mastering testing in your clinical practice with Dr. Tracy Stroup, who is on staff with us, who has been doing this intricately every day through the Get Healthy store. So she is the pro at it and going to be very thorough going through this. So if you're interested in mastering testing, you're not going to want to miss this. Also, if you're still fulfilling inventory in your office, we want to take it off your hands with Get Healthy Fulfillment. And this could be for brands looking for a single 3PL provider or for practitioners looking to get products to their patients. So we have Justine Stenger here, as I said, and I want to highlight her background so you can understand where she is coming from. She has received her degree in the University of Alberta in nutrition and physical education. She is also a holistic nutritionist and therapeutic chef. She has that certification from Bauman College, and she has completed her functional medicine training through the IFM, the Institute for Functional Medicine. And she is also a trained Bredesen practitioner, which is RECODE, and she specializes in cell membrane medicine and works primarily with patients who suffer with neurological conditions, mast cell activation syndrome, Lyme disease, and autoimmune disease. She has worked beside Dr. Bruce Hoffman for the past 10 years and has supported hundreds of Dr. Hoffman's chronic complex illness patients nutritionally. She has the background to support that. So she's an amazing clinical educator. So we're going to hand it over to her.
Thank you so much, Candice.
Of course, welcome. Pass the screen.
You know why it's not letting me present? Let me just refresh this here.
Okay.
There we go. All right. Perfect. Thank you so much for the intro, Candice, and thanks to everyone for being here today. I'm looking forward to walking you through how we can support mitochondrial restoration through using phospholipids and improving redox potential. Just a quick disclaimer, remember that none of these statements have been evaluated by the FDA, and this is not designed to treat or diagnose. This is for educational purposes only. So our agenda today, so we are first and foremost going to go over mitochondrial functions and just a quick overview of what the mitochondria are, where they come from. Then we'll go into understanding redox and how we can improve our charge. We'll go over causes and consequences of mitochondrial dysfunction. I don't even like to call it dysfunction anymore. Really, the causes and consequences of mitochondrial shifts in metabolism and the disease implications. We'll go over the cell danger response and the mitochondria. And then I will get into phospholipid therapy and fatty acid therapy to support restoring the membranes and overall support restoring mitochondrial function. And then at the end, I'll go over some case studies and lab assessments with you, and we'll quickly go over some of the tools that we can use through dietary measures to support mitochondrial function. So What are the mitochondria? So first and foremost, we have about 37 trillion cells within the human body. We have over 200 different cell types, and we have over 500 trillion mitochondria. Now, I will talk about this more in future slides, but we want to really remember that every single one of those cells, every single one of those cell types, every single one of those mitochondria have two lipid bilayers. So our outer membranes of every one of those cells have these two lipid bilayers that are rich in phospholipids. On a mitochondrial level, we have an outer membrane, which is rich in phosphatidylcholine, and an inner membrane, which is rich in phosphatidylethynolamine. And that is where oxidative phosphorylation occurs, which again, we'll get into deeper in a few slides. But remember that the mitochondrial membrane plays such a critical role in energy production. It houses the electron transport chain. It is where we make water that turns into a biological battery within your cell, and where we make ATP. So the membrane is what regulates the passage of molecules and ions, both in and out of the mitochondria. So this is impacting, I would say, all of our cellular processes. So when we think about metabolism, apoptosis, cell signaling, we always want to be looking at the mitochondria. So the mitochondria come from our mom. 100% of the mitochondria in your body came from your mother. And they are located in all of our cells, with the exception of red blood cells and the exception of corneal epithelial cells. And then we have different concentrations depending on the tissue, the organ. So we have really high concentrations in the brain, in skeletal muscle, in our liver, in our kidneys. And if you look at all of those different organs, we know based on the chronic disease that we see today, those are main organs that experience disease, right? So these are bioenergetic diseases, which is why we want to support and focus on mitochondrial medicine and restoring the bioenergetics within the body. Now, each membrane, both outer and inner membrane, is going to be a little bit different in both appearance and function. So I mentioned that the mitochondrial membrane, we have two lipid bilayers. So the outer membrane is rich in phosphatidylcholine. That is the most abundant phospholipid in the entire body. That inner membrane is rich in phosphatidylethynolamine. Now, that inner membrane is also synthesizing another lipid, phospholipid, called the cardiolipin, which looks molecularly very different than the other phospholipids in the body. It actually has 4 fatty acid tails versus 2. And I'll talk a little bit more about the cardiolipin in a few slides here. But the cardiolipin is really important because it is maintaining the structure, that curvature of that inner mitochondrial membrane. It is ensuring that the protein complexes are staying closely packed together so that we don't experience swelling. Because remember, when we experience swelling, those electrons are not going to make it to the protein complex. So they're going to react with oxygen and generate reactive oxygen species. So key to supporting mitochondrial function is making sure that we keep those protein complexes tightly packed together. And the cardiolipin helps to ensure that this happens. And the cristae, which is the curvature in that inner mitochondrial membrane that's housing the electron transport chain, we have all of those curves because we need to, or it's to improve the surface area so that we are able to generate more energy. So cellular respiration, we all know, is a metabolic pathway that breaks down glucose and produces ATP, or fatty acids, or protein to produce ATP. Ultimately, proteins, fats, and carbohydrates, they are all getting broken down to protons and electrons. The electrons are entering the electron transport chain while those protons are getting pumped into the intermembrane space. Now, the functions of the mitochondria. So we have kind of the conventional view of the mitochondria, and I think all of us here were taught that the mitochondria are the powerhouses of our cells. They're these little energy factories. And we have reduced the mitochondria down to that simple function. Meanwhile, we've neglected all of these other functions of the mitochondria. And some really interesting things to observe as I learn more and more about mitochondrial medicine and their functions, that a lot of the things that we would consider byproducts are actually some of the most important things that the mitochondria do. For instance, CO2, we have referred to that as a byproduct, and we know that that is critically important for helping to get oxygen into the mitochondria. Infrared light, which we kind of neglected as a byproduct, so important for that biophotonic signaling, for the generation of heat. We also know water on complex 4. We called that a byproduct for the longest time, and the water is creating a biological battery in each and every one of your cells. So definitely not a byproduct at all. So we know that from a function level, mitochondria make ATP, they make water, they make CO2, they regulate cellular metabolism, they're involved in calcium storage and signaling. They are involved in the production and regulation of reactive oxygen species and reactive nitrogen species. Again, these were considered bad, even in the functional medicine today. We still classify these reactive oxygen species and nitrogen species as bad. These are signaling molecules. These are biophotonic signaling molecules. So definitely not bad. They're necessary. It's just when we have, imbalances within redox potential that they can cause problems. They are controlling apoptosis. They are regulating cellular growth and differentiation. They are involved in thermogenesis. They are involved in the mitochondrial dynamics of fission, fusion, mitophagy, in the innate immune response, in hormone synthesis. Our mitochondria make pregnenolone. So they make this master hormone that is making all of our downstream hormones. So mitochondrial function is intimately connected to our ability to make healthy levels of hormones. Mitochondria are intimately connected to your lifespan and health span. And they should be what we are targeting if we're looking at anti-aging medicine. It should be mitochondrial medicine that we're targeting. Now, one of my favorite characteristics of the mitochondria, being in the vitalist, being in the world of vitalism and really believing that the body has this innate ability to heal on its own, that we don't need to be applying brute force for healing. The mitochondria are our sixth sense. So they are sensing organelles. They are sensing the internal environment for threats to make sure that it's safe for the host. They're also these electromagnetic sensors that are sensing the external environment as well. And understanding this and this specific quality of the mitochondria has completely and totally changed my perception of human health. Because when you know this and you understand this, it's these illnesses that we often see, we always have to think of them as environmental illnesses. What is the environment that the individual is in? Because when the mitochondria are detecting threat, they are going to shift metabolically. And we'll talk a little bit more about that when we get into the cell danger response. They're also involved in redox sensing and involved in the production of infrared light and heat. So mitochondria, the essence of the mitochondria really lies within their ability to generate energy, to maintain metabolism, and to regulate signaling cascades and sense danger. And as fundamental constituents of numerous cellular processes, the architecture and the proteome of the mitochondria are critical to intracellular biochemistry. So this is where membrane medicine comes into the picture. The behavior of the mitochondria is subjugated to the environment of the organelle. And anytime we have perturbations of mitochondrial homeostasis, that is going to prompt pathophysiological conditions to arise. And I love this image because it just highlights so many of these functions that we just talked about when it comes to the mitochondria. So let's just quickly go over energy production as a review. So first step in energy production would be glycolysis that occurs in the cytoplasm. So that is the initial metabolic pathway that takes one glucose molecule and that converts to 2 molecules of pyruvate. That results in the production of a small amount of ATP and NADH. That's the wrong way. Then we have pyruvate oxidation. So each pyruvate molecule is going to undergo a process called oxidative decarboxylation. That's going to convert it into a molecule called acetyl-CoA before it enters into the Krebs cycle. And the Krebs cycle takes place in the mitochondrial matrix. So here we have the Krebs cycle, acetyl-CoA gets oxidized. So you'll notice here we have all these oxidation and reduction reactions happening here, or redox reactions. See, acetyl-CoA gets oxidized, leading to the release of carbon dioxide and the generation of high energy electron carriers NADH and FADH2. And those NADH and FADH2 are carrying those electrons. NADH is carrying electrons to complex 1, FADH2 carries those electrons to complex 2. And then as those electrons move through the electron transport chain or tunnel through the electron transport chain, they are releasing energy, which is used to pump the protons into the inner mitochondrial membrane, creating this electrochemical proton gradient, this charge within the membrane. And we have, within the mitochondrial membrane, we should have a charge of about -180 to -200 millivolts. And that charge is actually more potent than a bolt of lightning, based on the size of that membrane, which is really, really fascinating. That's based on Dr. Nick Lane's work, actually. And that proton gradient that's established by this electron transport chain is what drives protons back into the mitochondrial matrix through ATPase. So depending on that charge is determining how well you're making energy. And that potential we'll talk more about when it comes to redox, but the charge is key. So keep that in your head. ATP synthesis uses that energy from this proton flow to synthesize ATP from adenosine diphosphate and inorganic phosphate. Now, I do just want to say that this has not been proven in especially conventional science, but Nick Lane does talk about, his book is excellent if any of you want to learn more about mitochondrial medicine, sex, power, and suicide, mitochondria and the meaning of life. But he talks about in that book that what he thinks is actually happening, instead of the electrons generating the energy that are pumping those protons into the inner membrane space, that maybe those protons are actually jumping on the hydrogen bonds of the water within the mitochondrial matrix. So we'll see if that actually comes into textbooks. So redox, I talked a little bit about that just in the slide before. We noticed all these oxidation and reduction reactions. So what exactly is redox? I'm going to refer to redox a lot over the course of this presentation. Oxidation is just the loss of electrons by one molecule, atom, or ion. So that's going to lead to a decreased positive charge or a decrease in negative charge. So an example of that would be when a molecule like glucose loses electrons during cellular respiration, that becomes oxidized. Reduction is the gain of electrons by a molecule, by an atom or an ion, that's resulting in a decreased positive charge or an increase in negative charge. And an example of that would be a molecule like NAD that gains electrons, it becomes NADH. NADH delivers those electrons to complex 1. And these reactions are always occurring together, where one molecule is becoming oxidized and another molecule is becoming reduced. And so redox potential is a general term that's used to describe these concentrated zones of electrons and their net negative charge. And in some instances, it can also refer to the concentrated pools of protons and their isolated positive charge. But I want you to really remember this, that redox potential represents the electrical charge itself and what your body is able to do with that voltage. So this is intimately connected to health and disease. When you lose that charge, when you lose that redox potential, that equals disease. When you build that charge, that equals health. Now, as a clinician, in order for you to measure redox, there's lots of ways that we can measure redox. Basically, you're just going to talk to your patient because where we have symptoms manifest is a sign that we've lost that charge. We have poor redox in that area. But redox is largely a function of how well you, as an individual, can turn the food that you eat, the sunlight that you're exposed to, and the Earth's electromagnetic field into a DC electric charge. That DC electric charge is generated by those electrons that are moving through the electron transport chain, while at the same time minimizing the loss of electrons from modern day living. And unfortunately, we are being bombarded with assaults that are decreasing our charge and leading to severe illnesses. So redox is the energy behind health and resiliency, healing capacity, movement of materials, chemical reactions, and ultimately life itself. And when your redox is optimized, your biology is full of life. When your redox is poor, your body lacks the energy to maintain itself. Now, we can test redox through lab markers, because negative charge and alkalinity are synonymous with health and healing, positive charge and acidity are going to create inflammation and disease. So if you had to pick two metrics as a clinician to assess your health, you'd want to test electrical charge. There's very few labs that are doing this. And you also want to test pH, because those give you a lot of insight. And those two, when you look at those together, they work in like dance partners. So oxidation is stealing electrons. Cells and atoms are going to gain a positive charge. So that means more corrosion, greater instability, more inflammation. And that inflammation doesn't know how to quit, right? It's like a hamster on a spinning wheel. And that means your cells are falling apart and unable to repair themselves, which is going to result in disease, sickness, aging, and eventually death. And we see this at mass numbers today. Then we can look at oxidative stress markers. So you can look at things like antioxidant enzyme activity, so superoxide dismutase. You can look at glutathione levels to get an idea of redox. And then you can also look at lipid peroxidation markers like malinaldehyde. That's another great marker to look at. And then if you have the ability to measure phospholipid concentrations, this is also a great way to assess redox. But then you want to talk to your patient, because anytime you have poor GI health or inability to digest the food that you consume, your immune system function, wound healing, your hair, your skin, your nail quality, your sleep quality. So always be asking patients about dreaming. The bun and creatinine ratio, when that's high, that is an indicator that your proteins and mitochondria don't have enough water, mycelials around them to actually transfer energy to and from. So this is a sign of cellular dehydration. So you can look at that clinically. You can look at intracellular hydration. You can look at phase angle, and this is done in a lot of clinics. Low levels of LDL. This is a sign of poor redox. So very different than what you're going to be told conventionally. Brain fog, neuropathy, cardiovascular health, hormonal imbalances, degenerative disease. Libido is another really good one, and cataracts. These are all signs of a loss of redox potential. Also, mitochondrial dehydration. So when your mitochondria have shift functioning, that dehydration impairs mitochondrial function, because water is actually critical for generating ATP and maintaining that mitochondrial membrane potential. So reduced mitochondrial hydration is going to affect the electron transport chain and increase oxidative stress. And then again, this is just like a vicious cycle, because the more dehydrated your cell is, that redox water, that exclusion zone or coherent domain water, this is a redox molecule. So that water can actually provide electrons to the electron transport chain. So the more dehydrated the cell becomes, the more unable the mitochondria are able to make water, then the more dehydrated the cell becomes. So again, it's this really vicious cycle. And so when you're looking at that bun ratio, which is an indicator of dehydration, which impacts mitochondrial function and leads to increased levels of oxidative stress, that can provide you with some really valuable cues about underlying conditions that are going to impact redox. Now, there's a whole field of research that studies how we can support improving redox through using phospholipid and essential fatty acid therapy. So redox lipidomics examines how lipids influence redox processes and biological systems. And it involves the comprehensive analysis of lipids in cells. So we'd want to be testing specifically the mitochondrial membrane. You'd want to test the levels of phosphatidylcholine and phosphatidylethanolamine. And redox lipidomics even goes further into studying how lipids are modified during oxidative and antioxidative reactions, and the impact of these lipid modifications on cellular health and cell signaling. And the more and more that I learn about the qualities of lipids and how these membranes, how they're acting like semiconductors, the more reverence I have for these phospholipids and using lipid replacement therapy or phospholipid therapy to help to support people in improving their redox and ultimately improving their overall health. So I mentioned earlier the cardiolipin. So when we tie this phospholipid bilayer or this phospholipid into redox, this is critical for redox potential because the cardiolipin actually interacts with key proteins in the electron transport chain. So it is housing, if you can, this is where I need an inner mitochondrial membrane on this slide. So if you think about the inner mitochondrial membrane and all those cristae, all those folds in that inner mitochondrial membrane, the cardiolipin sits on top of that ethanolamine membrane, and it houses complex 1, complex 3, complex 4, and ATPase. So it is intimately connected to your ability, your bioenergetics, your ability to make energy. And those phospholipids are also contributing to our antioxidant defense system. Phosphatidylcholine specifically is a really potent antioxidant. So phosphatidylcholine and ethanolamine play roles in supporting the body's antioxidant defenses and maintaining cellular health that makes them two, critical additions to supporting patients who have poor redox. And then, of course, I can't talk about restoring mitochondrial function without talking about all the essential things. So yes, the lipids are essential, and we can't just use lipids in isolation. We have to teach people about light and dark cycles. Your body, everything that happens on a cellular level happens according to very specific timing mechanisms. And we live in an environment today where the majority of people are living under an alien sun, and most people for the majority of the day. So we have created complete chaos. We've lost coherence within the body because of light exposure. And so as a practitioner, it is your responsibility to make sure that you are educating light and dark cycles and getting people's circadian rhythm on point. So we want to be watching the sunrise. That is setting the mitochondria up for optimal functioning. We want to make sure that we are not exposed to any artificial light after sunset. And we are really, really guarding that input of light into our eyes, like guarding it like nobody's business. Photobiomodulation, the sun is your best form of photobiomodulation. So we want to spend as much time outside getting bathed in that red and infrared light as possible. And again, this is more important now than ever. But we can also lean into using photobiomodulation panels, red and infrared light, to help to support our mitochondria. Those are essential nutrients for your mitochondria. Cytochrome C oxidase has chromophores that absorb red and infrared light. And without that, and most people are spending their entire day indoors on tech, completely devoid of red and infrared light. So we can't just be throwing, mitochondrial nutrients on people or supplements on people without actually giving them the nutrients that the mitochondria need. Using cold thermogenesis is a really powerful tool as well. And a lot of people say a lot of inaccurate things about cold therapy. We did not evolve as human beings to be in a climate-controlled environment 24/7. So for anybody that says, oh, this patient has autoimmune disease, we don't want to expose them to cold, or they have adrenal fatigue, we don't want to expose them to cold, that is nonsense. Your body evolved, your mitochondria evolved to be exposed to cold, not to be in the same climate 24/7 and 12 months of the year. We need to expose ourselves to different temperatures for optimal mitochondrial function and mitochondrial longevity. Of course, you want to start low and slow. If somebody has not been exposed to cold in a long time, you want to slowly acclimate. But that, to me, is not up for negotiation. It's an essential tool. We can also use baths, Epsom salt baths, to release the positive charge and to help with the expansion of that exclusion zone. This is an amazing hydration tool. Also an amazing way to absorb magnesium sulfate. And then we can also consume lots of fish, lots of marine and ruminant animals, four-legged animals. Movement generates piezoelectricity. So we actually create electrons through putting mechanical stress on our collagen, on our bone. So movement is essential. And again, it doesn't need to be exercise like in the conventional way that we think about it. The body was just designed to move, and we want to make sure that we are moving as much as we can throughout the course of the day. You want to avoid all alcohol. This is a redox sabotager. You also want to really be cognizant of fluoride exposure. So both in water, most people are familiar with the importance of getting water filtration, specifically that removes fluoride. But we also want to be careful about black tea and red tea due to high fluoride concentration. So if you steep tea and then just steep it for a few seconds and then discard that water and then make your tea, you are removing the majority of the fluoride. So if you can just practice that, you're going to reduce that intake by a lot if you're a tea drinker. And then we want to make sure that we're providing our body with clean, very clean, mineral-rich, structured water, so that we are supporting our cells' ability to generate that exclusion zone water and overall just giving our body the cleanest source of water possible. And this is also a big problem today, just based on the problems that we have in municipal water supplies and the contamination. Grounding, another essential nutrient. We live in a world today where we have completely buffered ourselves from connection to the earth. We're wearing rubber shoes, we're living indoors. Most people don't come in contact with the earth at all. This again is not up for negotiation. We were designed to be connected to the earth 24/7. So we need to make sure that we reconnect ourselves with the earth. There's specific surfaces that are grounding, like concrete, surfaces like wood, you're not going to be able to ground through. So just make sure that you know what those surfaces are so you can best support your patients. We want to make sure that we are following a membrane stabilizing diet that is low in carbohydrates so that we don't have these blood sugar peaks and valleys. And then we also want to make sure that we are eating according to circadian rhythm. We have 3 main things that regulate our circadian rhythm. Light is number 1. And then we also have food intake or food timing and movement and temperature to a degree as well. So we want to make sure that we're eating according to optimal circadian timing, as well as getting that light exposure and eating a diet that is local, seasonal, whole food, low carbohydrate to keep our cells as healthy as possible. We want to avoid non-native EMFs as much as possible. This is becoming harder and harder all the time in the environment that we live in, and it is so important. These non-native EMFs dehydrate you on a cellular level, not to mention create complete discoherence within the body, within biophotonic signaling, and damage our membranes, cause calcium to influx into the cell. I mean, the consequences are catastrophic. So we need to really make sure that we are paying attention to the environment that we're spending the most time in and doing whatever we can to create a sanctuary for ourselves where we spend the most time. And then really pay attention to clients that are wearing any wearables. You're wearing a Wi-Fi router on your body. So we want to get rid of all of the wearables. We want to get rid of Bluetooth. And this is something to pay attention to on your phone to make sure that you don't have that signal going. And of course, keeping your phone off or on airplane mode for as much of the time possible as you can. We want to really eliminate or decrease exposure to the best of our ability. Then we can use some specific tools to help to support the organelles within our cells as well. So of course, the phospholipids and essential fatty acids are number 1. And there's a number of studies that show that TUDCA, which is a bile salt, so TUDCA is cholic acid conjugated to taurine. The TUDCA has actually been shown to reduce the stress on the endoplasmic reticulum, and that has been shown to help to improve protein folding and lipid folding. So this is a tool that you can use, for people while you're working on building their redox to really support taking the stress off of that organelle. And when we take the stress off the endoplasmic reticulum, what is that doing to the mitochondria? Because they are married, they're working so intimately close together. When we remove that stress, we're also taking the stress off the mitochondria as well. And then butyrate, there's some really interesting studies on butyrate and mitochondrial function. I am such a huge fan of butyrate. So butyrate is a 4-carbon chain fatty acid. And most of you will know that it's made through a number of pathways. The main pathway is through the fermentation of dietary fiber. And it's the number 1 fuel for our colonocytes. So incredibly important for helping to keep those colonocytes healthy. to keep tight junction integrity. It's antifungal. It has many, many properties. It acts as an antioxidant, but it doesn't impact redox at all. So it's not like taking exogenous antioxidants and manipulating, trying to blast the reactive oxygen species, because now we know that's actually not the approach that we want to take, right? Those reactive oxygen species are signaling molecules. They are essential for helping the cell to get back to homeostasis. So we don't want to just be squashing them, but we can use these really powerful tools like grounding, your best antioxidant. And we can also use things like butyrate to help to support the mitochondria. This gets converted directly into acetyl-CoA. It can also get converted to beta-hydroxybutyrate in small amounts in the liver. The neurons can directly convert butyrate to beta-hydroxybutyrate, and it can be used as a fuel source. So if you're working with someone with neuroinflammation or post-concussion syndrome, cognitive decline, a really powerful tool to use this short chain fatty acid. And sodium butyrate is the one from BodyBio that I'm partisan to. So let's get into the cell danger response. The cell danger response single-handedly changed the way that I think about human disease. Now, we currently live in this model of medicine. I think there's over about 200 different specialties within medicine. So we have all these different specialties, and the more and more specialized you become, the more blind you are to see how everything is interconnected, right? Everything is interconnected with everything else. And so learning about Dr. Robert Navio's work in the cell danger response really showed me that when you look at all of these different diseases that we put into these little silos in silo medicine, and we treat these specific symptoms and these specific diseases, that really all of these diseases are coming to the same root. And that root is the mitochondria. And so if we can look at these diseases differently, and instead of looking at trying to force healing or symptom suppression, look at them through how can we actually support the mitochondria's ability to sense safety? That's number one. And then provide all of these inputs that are going to get the body, the host, back to coherence. And that is what I teach, and that is my goal for every one of you, because that is what health is. We can do symptom management all day long with these protocols and specific treatments for X, Y, and Z. But ultimately, we want to make sure we're just giving the body what it needs to do to get back to homeostasis, because the body is perfectly designed to heal. We don't need to force and push and pull. Healing is about flow. So, sorry, I went on a tangent there. The cell danger response is the evolutionarily conserved metabolic response that protects cells and hosts from harm. It is triggered by encounters with physical, chemical, or biological threats that exceed the cellular capacity for homeostasis. So if any of you have not read Dr. Robert Navio's paper, strongly encourage you to read his paper. It is, he's got a number of them. They're excellent. So it's not one thing, right? Now we know that it's not mold. It's not Lyme. It's not these individual things that we pathologize and then we treat and we tell a patient that they have SIRS. And we create that identity. We know now that it is a whole accumulation of all kinds of things that exceed the cell's capacity to maintain homeostasis. And in doing that, the cell danger response is triggered. So you can see here that all of these stressors, all of this load is going to trigger, oh no, peroxynitrate. And peroxynitrate is going to damage proteins. It's going to damage our membranes. And then what happens is ATP and DNA are going to go outside of the cell. And those are signaling molecules that are signaling danger. And so we have this whole cascade that we need to work to restore. And this is a beautiful image of the cell danger response where we have the health cycle that we go through every single day. And then we have the healing cycle that when we get stuck, when the mitochondria enter what Dr. Robert Navio calls as a cell danger response, our goals now as practitioners is to restore that back to the health cycle. So restore the healing cycle and move through these different stages of CDR1, 2, and 3 and get back to the health cycle. So what are these stages? So stage 1, you will all be familiar with this stage because this is when a patient comes to you and their cellular function is experiencing such a massive threat and it's in complete shutdown mode. So patients in this state are highly sensitive. Their mood is unstable. They are not tolerating foods. They're sensitive to supplements. They're just highly, highly sensitive people. And so under stress, the mitochondria are now going to rapidly change into a pro-inflammatory or M1 state. And they're going to engage in what's called antioxidative shielding in order to lower the damage control. This morphology is going to result in the mitochondrial membranes being replaced with saturated fats instead of polyunsaturated fatty acids. So the shift in the membrane architecture leading to stiffer membranes is directly linked to poor energy production, because we need those polyunsaturated fatty acids. The cardiolipin, all 4 of those fatty acid tails should be linoleic acid. And those polyunsaturated fatty acids are what provide this amazing fluidity. And provide that structure to the inner mitochondrial membrane to allow those electrons to move efficiently through those protein complexes and keep those protein complexes at the proper distance in the respiratory chain. So as soon as the mitochondria enter CDR1, they're going to toss out those polyunsaturated fatty acids and replace them for saturated. Now, there are people that do this just from dietary measures as well, especially with the whole narrative that linoleic acid is inflammatory and we want to avoid it. That's a consequence on a cellular level that we are impacting bioenergetics. Now, in CDR1, it's also characterized as a reduction in oxidative phosphorylation. So often cell death results in the release of the extracellular ATP. And again, that is a signaling molecule that leads to an innate immune system activation. So think about mast cell activation syndrome. This is a manifestation of CDR1. Now, this I want to highlight over and over and over again, because I see people doing this all day long. This is not the time to be detoxifying and killing pathogens. Your cells are highly protective and not healthy enough to engage in metabolically challenging processes. So we do not want to be giving binders and putting people on detoxification protocols and pushing and forcing healing. This is an evolutionarily conserved state. We got to honor that and allow the cells to get back to the mitochondria to get back to homeostasis on their own by providing the proper inputs. Now in CDR2, this is where we see the promotion of cell growth and the accumulation of biomass. So this is where we start to see aiding in cell regeneration. And you're going to notice as a clinician, when people move through CDR1 to CDR2, they're going to start to feel safer. They can tolerate more foods and supplements. Their mood is more stable. They're not as fragile as they were in CDR1. And once your cell membranes get repaired, tight junctions are established, then we can move into CDR3. And in CDR3, this is when the cell can return to differentiation. We have tissue remodeling. We've returned to normal, healthy detoxification, which happens naturally. And the organ-specific functions are going to start to improve. The main energy source, it's going to return to its more efficient means of generating energy. We have older cells getting replaced with new cells, and new cells are teaching the older cells how to behave. We see release of deeply embedded toxins in this phase. And the mitochondria are then going to go from an undifferentiated M0 phase to an anti-inflammatory M2 filamentous phase to produce more energy. So there's a return to oxidative phosphorylation in that stage. Now, Dr. Robert Navia, when you look up his paper, he has put specific diseases. This is kind of a perfect example of silo medicine. He's put specific diseases in each category of CDR1, CDR2, and CDR3. So you may want to just look the study up as a reference. I don't understand why some of these are placed where they are. An example would be, chronic fatigue syndrome, I believe, is placed in CDR3. To me, that would be a representation of CDR1, but I'll let you look up the paper and take a look at that chart that he has available. So inputs to restore the health cycle. There's a lot of them. And I have to give credit to Dr. Bruce Hoffman for teaching me all of these different things, because he does practice whole person healing and has always taught me that healing doesn't occur from just taking exogenous things. Healing occurs through many, many inputs, and ultimately the body feeling safe and getting those safety signals and us regaining coherence within the system. So self-referral, self-regulation. There's so many ways to do this. I personally find humming so powerful at helping to promote that regulation within my body. You're generating this really healing frequency. You're exercising the vagus nerve. So it doesn't necessarily mean that you need to be going and buying a device or sitting, meditating for 30 minutes. There's lots of ways that we can incorporate self-regulating tools throughout our entire day. We want to make sure that we are getting full spectrum sun exposure daily. We got to get ourselves outside. We need to get connected with the ecological system in which we came from. I believe that this is the main driver of disease today, that we've completely separated ourselves from nature in so many ways. We need to pay attention to artificial light, and we want to eliminate any artificial light, especially at night. I don't have time to get into all my teachings in this presentation, but there are many, many mechanisms in which just exposure to this alien light, even during the day, is detrimental to our mitochondrial health. We want to make sure that we are focusing on diet. Ultimately, food is photosynthesis. This is biophotonic information that we are consuming, and we need to be eating locally and seasonally, and again, keeping the carbohydrate load low so that we can allow the body to repair those membranes. We want to focus on loading our food in the first part of the day and making sure that we're not eating later in the day. This is to support circadian rhythm. This is to support leptin. This is to support optimizing our ability to digest and assimilate nutrients. Lots and lots of reasons why we want to prioritize that. Of course, sleep, this is something that's talked about all the time. I would just emphasize that it's so important to make sure that your sleep environment is free of any non-native EMFs. You want to create a little sleep sanctuary, a bubble that is devoid of these frequencies. So absolutely no technology, nothing plugged in. You want to make sure Wi-Fi is off. I go so far as to get people to shut breakers off in their bedroom and to get it evaluated so that we actually have a place where we can restore and we can heal because we are bombarded by these frequencies all day long. Stress, of course, management of that. We want to support our biochemistry through optimizing micro and macronutrients. I am also a major fan of the BodyBio Remineralize. They just launched this a few months ago. I have never taken anything that I feel so much life just by consuming it, and the water is just so hydrating. And that would be, really supporting mineral status in the body too is so key under this category of restoring biochemistry. We want to support detoxification through moving, through making sure that we are getting our circadian rhythm on point, because when you are doing that, your cells know exactly what to do and when to do those things. You leading into sauna therapy, again, cold thermogenesis, all of these tools are going to really help to support detoxification. And again, detoxification is about flow. It is not about forcing the body to detoxify. Of course, connection, grounding, I've talked about a lot. Movement, I talked about a lot as well. And family systems is something that I feel is so important. I've worked with so many patients that have worked with Mark Wolin, who does family constellations. And that has been such a huge piece to their whole healing journey. And also looking at early developmental trauma, amygdala retraining if people need that tool. And then again, structural issues are important to look at. There's a lot of people that have vagus nerve issues and just dysautonomia that NUCA chiropractors do such an incredible job of helping to support them because they're adjusting that C1 and C2. And so just keep that in your toolbox as well. That can be really helpful. And then we have phospholipids. So of course, I hope all of us know by now the importance of these phospholipids and how critically important it is to provide the body with these exogenous materials that are required to go in and discard damage to the membrane and replace that damage with healthy, functional phospholipids. And there's no greater product than the BodyBio PC. Their product is actually what was the catalyst to me going in studying phospholipids and fatty acids because of what I saw clinically. I just thought, this is so insane. Why are we not talking about this? Why are we not talking about this tool that we have that we can just give these people the materials that they need so the cell is able to do the work that it was designed to do? And so I'm the biggest advocate of using phospholipids and essential fatty acids to help to support repairing membranes and provide the body with that safety signal. And the fatty acids, 2 essential fatty acids are the ones that we focus on when using phospholipid and essential fatty acid replacement therapy. So that would be linoleic acid and alpha-linolenic acid. That's found in the BodyBio balance oil, which is a perfect ratio of 4:1. And again, just emphasizing, highlighting that linoleic acid is that main fatty acid that's found within the cardiolipin, within that inner mitochondrial membrane, and is absolutely critical for efficient energy production. And so this is really just a review slide on linoleic acid and the role that it plays within the cardiolipin. I just want to highlight here that when we are overdoing fish oil, and I won't get into all of the reasons why we don't want to be consuming fish oil in this webinar, but one of the main consequences of consuming these super physiological doses of oxidized oil, we are displacing linoleic acid from the cardiolipin. So that's going to result in this incorporation of DHA into the cardiolipin, and that completely alters the membrane's properties. It completely alters the way those electrons are able to move through the electron transport chain. It's completely altering the voltage. And so it's not what we want to do. And I would go so far to say that we can actually catalyze, mitochondrial problems, shifts in metabolism by just overdoing these essential fatty acids. So you want to make sure that you have optimal ratios of these two. Now, the DNA adducts were something that I'll show you on some of these sample tests that I have here at the end of the presentation. One of the main things that I saw clinically with the use of exogenous phospholipids, with the use of the BodyBio PC, was that it had the ability to actually remove these DNA adducts. So DNA adducts are just chemicals that are covalently bonded to your DNA. They can get covalently bonded to the mitochondrial DNA as well. And the effects of DNA adducts are going to, of course, depend on the position in which they're covalently bonded or what gene or gene segment that the adduct is bound to. But this leads to the permanent dysregulation of gene activity. And there's many, many diseases that are shown to be attributed to these DNA adducts. And so the fact that you can use phospholipids that are only supportive, that don't cause any harm within the body, these lipids that are essential, that we can use them to go in and remove these DNA adducts that have covalently bonded to DNA is just so phenomenal. Okay, let's go over some case studies here. So unfortunately, the IGL out of Germany is no longer available. This was this was the test that we ran for years. That I saw, complete transformation from the first test to the repeat test. And as you can see here, there's a number of markers that are tested here. They have a variety of different panels. And you can see here that this patient had really low levels of ATP. That whole ATP magnesium and ATP phoskinase activity was inactivated. This blocking of active sites, this would be because of toxins. So just lots, you can see here that the result was, significant mitochondrial dysfunction as kind of a synopsis from this first ATP profile. And then the same patient had an increase in cell-free DNA. So that is detecting, cellular fragments. These are linked to autoimmune disease. These are linked to cancer as well. You can see here that on the cardiolipin, you had mercury that was covalently bonded to the cardiolipin. You have low cytochrome C oxidase activity. So I just want to highlight the importance of the cardiolipin in helping to support that protein complex. And remember that protein complex needs red and infrared light to work as it should. And so if you're deficient in those wavelengths of light, that's going to dramatically impact the activity of cytochrome C. You can see this malonaldehyde level is high. So we saw that as a marker of redox, right? So there's lots of lipid peroxidation happening on that inner mitochondrial membrane. And you can see here that both phosphatidylethanolamine and phosphatidylcholine are both low. So these were the specific DNA adducts that were on this patient's results. She had mercury and a number of other, heavy metals and things that were covalently bonded to her DNA. You can see here that she also had low levels of glutathione, which is another redox marker, and lots of toxicity. So lots of toxins, these are intracellular toxins that were found. So lots of these intracellular toxins that were high or borderline high or even very high. Now, this was after about 9 months of phospholipid and fatty acid therapy. And as you can see too, we're doing a lot of other things. It's not just kind of isolated, just let's give someone phospholipids without educating them around what a human body needs to be healthy and well. But you can see here that these all normalized for the most part after the addition of the lipids. All of the cell-free DNA was normalized. This all normalized. So cytochrome C oxidase is normal. We had normal levels of malonaldehyde, normal levels of PC and PE. There was no DNA adducts found, so we removed all of the DNA adducts. And this panel completely normalized as well. So we completely restored this patient's redox potential using these incredible inputs. And when it came to her intracellular toxins, we also were able to remove a whole host of those intracellular toxins that were high, very high, and even borderline high. And then another test that we use clinically is the red blood cell fatty acid test. This is through BodyBio. They partnered with the Kennedy Krieger lab at the Johns Hopkins University, which is the gold standard for fatty acid testing. So this gives us this is the way that we are able to really personalize the lipid therapy for the patient. I cannot say enough about this test. I am truly enamored by this test and have studied it for years. But you can see here, this is kind of a classic example of what happens when you overdo the omega-3s. You can see this person is clearly supplementing with omega-3, which as a result has completely tanked all of her omega-6s. So we have got 4 main fatty acids that are found within the cell membrane: linoleic, arachidonic, DHA, and oleic acid. And so those 4 fatty acids are, of course, we have other fatty acids in the membrane as well, but those are our 4 most abundant. And so she has 2 on the omega-6 side that are completely tanked. Like arachidonic acid is the main fatty acid that's found within myelin. And so this is, an example of the reductionist take that we have on human health, that we are pouring fish oil into people, thinking that more is better and that it's this panacea. Meanwhile, we are completely depleting these other essential fatty acids that are essential for brain health and for the health of all of our cells. And then you can see here that it provides you with some guidance around structural components. So when you see really low levels like this of palmitic, of myristic, palmitoleic, oleic, this is usually a result of high levels of oxidative stress. There's lots of damage to the membrane. Of course, you always want to ask about dietary intake, blood glucose levels. All of those things are going to play a role in assessing these markers as well. But this test is invaluable. And it provides you with these DMAs, so you can get some insight into neuroinflammation, as well as there's specific fatty acids that are linked to neuroinflammation and issues with the delta-9 desaturase enzyme. There's tons of insight that we can get from this test. And just to finish up on diet, I know we're almost out of time, so I'll try to breeze through this, but we really want to pay attention to deuterium content. So I mentioned a couple of times in the presentation the importance of keeping the diet low in carbohydrates, and deuterium is one of the main reasons why we want to do that as well. So deuterium is an isotope of hydrogen. It's double the weight of hydrogen. So hydrogen is an electron and a proton, and deuterium is an electron and a proton and a neutron. And deuterium is going to be found in the air and in water, but it does accumulate in the seeds of plants and also in plants that have long growing seasons. So if you think about fruits, they're going to be higher in deuterium. Starches like sweet potato, those are going to be higher deuterium foods. Any grains, any beans, any legumes, those all have high deuterium. And so deuterium is a mitochondrial toxin. When you think about the ATPase, the nanomotor on the ATPase or complex 5, because the heaviness of deuterium, that's going to outcompete hydrogen for going through that ATPase, and it completely blows up the nanomotor complex. It completely damages it. So this is really an interesting topic. I've been studying this pretty extensively lately, just because of the role that deuterium plays in cancer. And there's Dr. Gabor Somali is the lead researcher in this field, and he studies deuterium depletion for cancer therapy. And it's pretty phenomenal, the results that he has got. But when you understand how detrimental this is to mitochondrial health, you really will adhere to local and seasonal eating, because we do not want to be eating foods that were grown outside of our local environment because of the deuterium content. We're gonna load up the deuterium, and we're not in an environment, all of us, that we can actually deplete that deuterium adequately. And then for membrane stabilizing diet, of course, we want to make sure that we maintain blood sugar stabilization. This is so key. We want to focus the diet on bioavailable animal foods, ruminant animals, egg yolks, fish, also organ meats, also important for providing us with the nourishment that we need to build healthy cells. We want to support with phospholipids and essential fatty acids. And again, I feel this is more and more important every day as we continue to weaponize our own environment against us, to give our body that nourishment so that it can actually go in and repair damage is so essential. And then, of course, we want to make sure that we are not eating anything from a package, anything from a bag, anything from a box. We're not eating genetically modified foods. We are really conscious about our food intake because we are literally consuming the bioenergetic blueprint of the food that we are eating. And it's not just about macronutrients, micronutrients, phytonutrients like we're told. Thank you so much.
Awesome job, Justine. Great info. And my favorite part of it was just some of the day-to-day things that you talked about that we really need to hone in on and realize that those can, help with our longevity. No lights after dark. They say go to sleep with the sun and rise with the sun. The EMFs in the home, shutting that off at night. It's, all those things around us that, we don't see the instant effect, but long-term, can really do damage on our mitochondria. And then I thought it was interesting, like people go back and forth about the cold plunge and the hot saunas. You're right, we aren't meant to be climate controlled. So I have always thought, like, I don't think cold plunging is, for me, but you kind of made me think like maybe it's not so bad, but a little cold for me.
Yeah,
but
it's not bad at all. It's really essential when you understand how critical that is for the mitochondria. And I didn't mention this in the presentation, but through cold therapy, your mitochondria actually generate UV light. And so if you live at a latitude that you're not getting exposed to that strong solar yield all year, you absolutely want to be doing cold therapy because you want to be generating that internal UV light that is so critical. So yeah, and the frequencies, we forget, Candace, that the electromagnetic, the scale of electromagnetic frequencies, these are all light. Like we are light. We are regulated by light. So just because we can't see them doesn't mean that they are not having a massive impact on our health and on the coherence within our body with how our cells communicate. And this has all been studied. This is not my work. I've had, I love learning and love being able to synthesize the information that I learn and kind of connect the dots. But it's really devastating to think about what we've done to our environment and continue to do.
Yeah, I agree. We do have a question. If you could give directions on EPA and DHA, and if there is DNA predisposition to low function of enzymes and how we metabolize those?
Yeah, so the proper ratio of linoleic to alpha linolenic is about a 4:1. So that's been studied by Yuta Solomo he's the lead researcher in this field, and there's a couple of others that have determined that that's the ideal ratio. The enzymatic activity, the delta 6 and the delta 5 desaturase enzymatic activity is going to be completely dependent on the health of the individual. Now, in a healthy individual, I don't know how they determine that today, but in a healthy individual, the conversion on the omega-6 side from linoleic acid to arachidonic acid, you're looking at about 2%, possibly up to 5% in certain individuals, but it's very, very poor. So this is one of the reasons why I always say that this narrative that linoleic acid drives arachidonic acid is completely untrue. And having low levels of linoleic acid and elevated arachidonic acid is, of course, it's not diagnostic, but it's clinically associated with cancer because it's a sign that you're pulling arachidonic acid from membranes to make new cells. And so what determines the enzymatic function is going to be largely how hydrated your cells are. Those enzymes, that exclusion zone water that I talked about, is going to build around these enzymes and proteins and provide that charge for them. And so when you're working with individuals that are dehydrated, which honestly, I don't think that there are very many people walking the planet that aren't anymore, again, largely based on our environment. The enzymatic activity is not, I don't even think it's going to be 2 to 5%. And I see clinically, chronically low levels of those downstream metabolites, even if you have sufficient parent oils or essential fatty acids. They also require nutrient cofactors. So you need things like zinc and magnesium and B6 and B12. Folate is important. So there's lots of cofactors that are required too. So you'd obviously want to do a dietary assessment, but there's no way to actually determine how well the enzymes are functioning unless you're running, you can get insight if you're running a red blood cell fatty acid test from the Kennedy-Krieger. That's the only way that I would know how.
Okay. Well, thank you for answering that. And just one last question. I don't know if there's an answer to this. I'm pretty familiar with the BodyBio line of products. You talked about TUDCA, you talked about like a remineralizing product and, butyrate, of course. But if there was a product for somebody who is, day-to-day lacking these things, trying to get out in the morning sun, but then they go to work and sit under the lights all day, is there like a go-to product that BodyBio recommends for that? Or is it kind of based on, someone's profile and, where they're at with their individualized health?
Well, I mean, it's going to be so individual, but I would say my favorite product is the PC. I think that phospholipid complex is something that I would say everyone needs to be on. Yeah. And of course, the minerals are and trace minerals and macro minerals, they're so important. And
they're essential,
yeah, and amino acids in our, you want to really prioritize those essential nutrients because our body is able to, make most things and recycle most things on its own. But you'd want to prioritize those essential things. And then the PC, I'm just the biggest fan of the phospholipids.
Yeah, sure. Well, awesome info, Justine. Thank you so much. This was a really good lesson, great info, good overview on some of your products. And I think I'll have to rewatch this to cover a few more things, but great info, and we appreciate BodyBio. For anyone out there at the Get Healthy store watching this, don't forget to, add these products to your store. If they're not there already, you can go into the catalog and add these to your store. Just one last message for anyone who's on here live with us. We do have quite a few participants live. If anyone has questions, feel free to jump in and ask. But I think Justine covered just about everything. We'll hang on for a few more seconds and see if there's any other questions. I know there's been some chat. We do have some things coming in. Okay, Justine, what test has replaced the LPL test?
The IGL, there hasn't been a replacement for it.
Okay.
Yeah, not yet anyway.
All right.
Yeah.
Good to know. How are you moving mycotoxins without killing the mold, such as use of antifungal medications?
So I don't treat anything. I teach mitochondrial restoration. And when you mold toxicity or mold illness is individual in the cell danger response. So I'm not a fan of forcing anything out of the body. Your body knows exactly how to do that when you restore coherence. Now there's definitely tools that you can use. The PC is like the most potent detoxification tool that you can use because of just the nature of the molecule and all of the qualities that come with PC, with supporting methylation, with supporting liver health, with improving bile flow, with improving bile production. So again, I'm not in the camp of believing that we need to be doing all those things. I see patients get well every single day by just the basics. That unfortunately aren't being taught mainstream.
Yeah. I think just one last question. It's about tropical fruits, and kind of what's the take on that?
If you live in a tropical environment, then eat tropical fruits.
Mm-hmm.
If you don't, then don't eat them. Food is biophotonic. It's stored solar energy. That's what food is. So you want to make sure that what you're consuming is consistent with the environment that you're in.
Yeah. Yep. And then people say like eat what's in season and what's local to you. So I can respect that. Another question coming in, what is your take on using bioenergetic devices to restore energy flow?
Again, I don't want to say like make anyone wrong for using those because I think that we have to be so careful with that. I mean, I think that in some situations you may see improvements, but I would say look at Robert O. Becker's work, read The Body Electric, and I believe fully that we can restore so much of what we're seeing today through infrared and UV light. I really do. And he shows that in his research that got censored and squashed. And yeah, and just always keep in mind too, like these machines are plugged into a 60 hertz electrical system. And we are an electric body with a DC electric current flowing through our mitochondria. So anytime the body is very, very sensitive to these artificial currents. So you just want to always keep that in mind.
Great answer. Thank you. That's everything. That's all the questions. So we're going to wrap this up. We appreciate this so much. And thanks everyone for watching.
Thanks so much.